going to do two problems of factoring with complicated trinomials where the a coefficient isn't 1. I'm going to use the grouping method instead of the guess and check way. I prefer this way for most of the time just because I'm not a very good guesser, I guess. But it's just more direct this way. So here we go. 3x squared minus 22x plus 24. Now the first step is to multiply the a term and the c term. And this can be a really large number. In this case, it is pretty big. And so that discourages students from doing it. 24 times 3. But you have a calculator, and it's not that bad. So now I have 72, and this is the number that I want to list factor pairs for. And I know that the signs, because I have negative and then positive, have to be negative and negative inside my binomial parentheses. And so I'm actually going to be looking at factors that are both negative. So I usually pick 1, then I go to 2, and our middle has to come up to be 22, as we see over here. So maybe I'm wasting time to do 1 and 72 and 2 and 36, but if I'm not sure, I'll just do it anyway. It's not going to take that much longer to write it all. And I'm looking for both of the factor pairs to add up to 22 because they're both negative. They're going to combine in a combined effort, make that 22. And right now I've got too large of numbers, so try 3. That's going to be negative 24. Still too big, that's 27. And then I try 4, end up with negative 18, and I stop because I noticed that negative 4 plus a negative 18 gives me that negative 22. So that's my factor pair that I'm going to pick. And now the grouping way, you actually turn your trinomial into a 4-term polynomial and you factor by grouping. So I'm going to keep the first and the last term just the same and then create a new middle term. I'm going to turn that negative 22x into a negative 4x and a negative 18x. So now I have 2 terms instead of that one 22 term. And factor by grouping says, okay, if you've got 4 terms, look at the first 2 and see what's in common, pull out their greatest common factor. Well, they don't have anything in common except for an x. So I'm going to pull out the x and write the leftovers after I divide out an x from each term. So if I divide x out of the first term, I'm left with 3 and 1x. And do the second term, I'm left with a 4, negative 4. Then I can look at the next 2 terms and say, okay, what's in common with these 2? And then hope that I end up with the same leftovers, or I can think, okay, well, I know that it has to match my other leftovers, or I'm not going to be able to factor more. So why don't I just pick it up and copy it, and then figure out the value that I need to multiply in front to give me back those last 2 terms right here. So I need a negative 18x, and right now I've got a 3x. Well, cool, all I need is a negative 6 to be multiplied. So if I say subtract 6 here, then when I multiply my negative 6 to my 3x, I get the negative 18. And when I multiply the negative 6 to the negative 4, I get the positive 24 back. So that negative 6 was the key missing piece there. And now I can keep factoring because now I only have 2 terms. I have this x times term and this negative 6 times term, and they both have something in common. Well, they have the binomial in green in common, and so I can divide out that common binomial. It's a little bit more complicated than what you're used to pulling out, like a number or an x, but it's still something common. And then we can write what's left over after doing so, just like we did in the earlier steps. Well, if I have x times 3x minus 4 here, and I divide out that 3x minus 4 binomial, I'm left with x. And if I do the same thing to this term over here, divide out a 3x minus 4 term, or binomial, then I'm left with the negative 6 out in front. So it's really easy to pick off what's left over. Well, now I've got a binomial times a binomial, and I've factored the original trinomial up here. Let's try another one. This one is even more complicated. If we do the guess and check method, because we have a 10 and a 12, we have lots of options. We can have 1 and 10 or 2 and 5 for the first terms, or we can have 1 and 12, 2 and 6, 4 and 3. There's lots of different combinations that would work, and so if I just guess and check through all of those, it gets a little crazy. So I like to do the grouping way. Our first term coefficient is 10, and our last term is negative 12, and so we've got 10 times 12, negative 12, and that's negative 120, and that's a pretty big number. But I have a calculator to break it up, and it really doesn't take that long to list the factors. This time, because we have the signs of negative and negative, we know that we're going to have our signs be a positive and a negative one. So I'm going to have one of my factors negative, and it needs to be the factor that's largest, because that's how I end up with a negative in the end when I add them together. So I'm going to write negatives on all my larger factors. We've got 1 and negative 120, 2 and negative 60, 3 and negative 40, 4 and negative 30, ooh, 5 even works, 5, negative 24, and these are still quite a bit bigger than 7, so I'll keep going. 6 and negative 20, if I added that, that'd be 14 negative, okay, 7 won't work, 8, negative 15, and now I've reached factor pairs that are 7 away from each other. And so I've found the one that I need to break up my middle term into. So since 8 minus 15 is negative 7, I can rewrite this negative 7x as 8x minus 15x. And I keep the other two terms, the 10x squared and the 12, negative 12, the same. So now I've created an extra term. I've got 4 terms. I can do factor by grouping. Well, the first 2 terms there have a 2 factor in common and an x factor in common. So I pull out a 2 and an x and write my leftovers after dividing out the 2x. 10 divided by 2 is 5, and I divided off an x, so we've got 5x left. And positive 4. 8 divided by 2 is 4. Alright, I'm going to pick that up and copy it over here, because I know that I need to have that matching. And what do I need to get my next pair of terms there? Well, I've got a 5x, I need minus 15x, so I need a negative 5 out in front, or negative 3 out in front, sorry, 3 times 5 is 15, to get that negative 15, and then if we check with that 4, negative 3 times 4, yep, that'll get negative 12. So I've rewritten those 4 terms into 2 terms that happen to have something in common. They have a binomial in common, that 5x plus 4. So I'm going to divide that out from my 2 terms. If I divide it from this first term here, I'm left with the 2x. And if I divide it out from the second term, I'm left with the minus 3. And we're done. We've now factored our trinomial in the beginning into 2 binomials that are multiplied to each other. Something times something Just like if we had a number like 4 and said, well, what's a factor? 2 times 2. We've got it down to something times something. You've got to remember to not stop at this stage right here. A lot of students do that. They get all the way to there, they do all the work, and then there's just that one last little step where you pull out the common binomial to get it down to some binomial times another binomial instead of a subtraction or a plus between, like right here.